Guys, welcome back. So I've been really interested in brushless BLDC motors, brushless DC motors that have the three connectors. And for years, I've had this controller, which I assumed was a BLDC controller. That's what it said when I bought it on Amazon. And oops, that one came out. Um, and so I downloaded some STLs to make a real simplified version of a BLDC motor, just so I can get up to speed on the winding, the wiring. And I think I pretty much got it. Well, I decided that I wanted to buy just one of these off the shelf, very inexpensive brushless motors that they use for RC cars and boats and planes and all that. And I've got it hooked up to this controller. But I think I might be missing something because it's not working. It'll start to spin, then stop, and start to spin, then stop. I've got 12 volts going into it. Hold on, let me reconnect the negative and I'll bring you right back. Stay tuned. All right. So I reconnected the negative. The switch is on. The potentiometer is off. And look at what the motor does when I turn it on. And then it will stop. So I assumed that the controller had everything in it. I don't know if I'm running it at too low voltage, 12 volts. I figured that's pretty standard. Or if I'm missing something in the configuration here. I didn't think I was missing anything. I know that you can rearrange these, making this A and this C, switching them is supposed to reverse the motor, according to everything that I've read. And I've tried switching them around and it does the same thing, except if I don't make this A or this C or this A or this C, it doesn't work at all. So I know that's right. So here, let me show you again. And then once the motor, I guess, is full of flux, it doesn't do anything. I have to unhook it. So this has a potentiometer, and it's got an on and off switch, and it has a bunch of MOSFETs or transistors on here. So I don't know if I'm missing something, if this board is just bad. And again, I just did this because I wanted to play around with it. I was actually going to take this guy apart to look at it. But I got it, it was very inexpensive. I got it just to see if this controller works. And, I don't know if I'm missing something or what. Everything that I've researched said this thing should go. So I'm thinking maybe I've got a bad transistor on here. I really don't know how to check this completely out. It seems like everything is working. I turn it on, I get a red LED. And it starts to go, and then it stops. That was the most it's ever done, period. So if you guys can help me out in the comments, I'd really appreciate it. Again, I don't know a lot about these BLDC motors and their windings. I know that they're wound in either a delta or a star configuration. One gives you more speed and less torque. The other one gives you more torque and less speed. And I think the star configuration gives you more speed, so I'm assuming that's what this is But again, I'm going to take this guy apart anyway because I want to see what it looks like on the inside. Um, and again, I built this little test rig that'll. And again, this guy only has 6 poles, but I can still wind it, skipping every other pole. I can wind it in a very small delta configuration. Um, I've also downloaded a more robust, more pronounced or detailed model of a BLDC motor. And so I'm practicing the windings on this guy, but I wanted to first see if this controller is any good. And again, that led me to here, where I'm getting that spudding. Anyway, I'm going to continue playing around. I'll bring you guys up to speed in a little bit. Stay tuned. So I can't really tell just by the way this is wound if this is in a delta or star configuration. I think it's in a delta configuration. But what really surprised me was the rotor. The rotor's got permanent magnets. I mean, I knew it did, but I didn't realize how strong they were. And they're set up where north, south, north, south, north. The same way I build my motors, the same way I build my quote unquote brushless motors. Yeah, this is north, this is south, and this is north. So it has alternating poles, and it is very, very strong. I put it inside there, and let me see if I can do this one-handed. Yeah, one of the screws was bad. Go figure, you buy that cheap junk. All right, well, I can't do it one-handed. Let me see if I can. All right, let me get my third arm. All right. Yeah, it's pretty strong in there. So strong that I need a pair of pliers to pull it out because of the iron wall, the iron inner wall of the coil. What I wanted to do was to get the coil out, but I don't think I can do that without seriously damaging it. Maybe I could, if I could get this end off. Anyway, I'm not going to be able to do anything with this today. I ordered some more stuff. But yeah, if I take my pole finder here, south, north, south, north. Yeah. And it has little bearings in here. Anyway, I thought that was very interesting. Oops. And if we look at it through the magnetic film, you could see that the poles are sticking straight out. Now this is marked with some blue putty or blue tack or something. And then there's a black line there. I'm not really sure what that's all about. I'm sure somebody will tell me. I could put it in upside down like that. But I don't want to do that. So let me get this guy out. All right. I can't do anything today because I'm waiting for magnets for this guy. I'm also waiting for magnets for my Resign 3DP motor that I'm building, what I can do is I can wind these coils for the Newman motor, the new Newman motor from Design R3DP. But I also have, where is it? Yeah, I'm waiting for magnets for this this guy here. I forget what this is called. Anyway, yeah, I'm waiting for magnets for that too because I don't have the right size magnets. I need magnets that'll fit in the rotor here. I've got the bearings. I can check those out. They came in. But the same magnets that I ordered for this will also work in this, and I ordered a bunch of them. So I think this is like an inch. The ones that I got for that are like a ½ inch, but that's okay. It doesn't have to be precise. Anyway, let me get something else going so that I have something for this video besides me spouting off what I don't know. Stay tuned. So I always have Old Faithful to play with, massive output. So I took the iron core out, and so it's, let's see what happens when I slowly put it back in. Oops. You can hear the speed picking up. And the light dims a little bit, but then it regains its... God, that thing is flying. This is a fantastic circuit. It's not such a bad coil either. Let me get a big magnet on there. See if that does anything. Oops. Yeah, she's flying. Let me see what kind of RPM we got going on here. Solid output. $2,100. Yeah, 2135. It's staying right there. Let's pull it out. 2,200 and climbing. 2,300. Oh, wait a minute. Let me see if I can get you guys in here at the same time. 2,390. 2,400. We've been here before. I'm going to test out some different coils. All right, stay tuned. So remember when I was messing with this coil and I couldn't figure out why it wasn't working? The flux was going the wrong way. Now it's working just fine. I didn't think it would really matter. If I tilt it like this, it works. But going straight on, it works now, but I got to get it going, which is really weird. And if I tilt it, so all the flux is on the end there, all the magnetic, or if I do it like this is where it really shines. Working now just fine. Let me get this piece out of here so I can get it more centered. Yeah, when I tilt it that way, it speeds it up. Or if I tilt it that way, it speeds it up. So there's nothing wrong with the coil. It's my brain that has something wrong with it. But it really likes to sit that way. That way I get maximum output. But I need to drop it down so it's more in the center. So let me bring you back. Stay tuned. Yeah, now she's cooking with gas. That puppy's really flying. And it's not even that close. If I put it closer, it really gets going. But I gotta hold it. So now let's see. Yeah, if I put it like that, it works just as fine too. There, let me. This way it works the best. You can hear it speeding up. I mean, it's really flying. Let me take a reading. We're just getting up to speed now. It's still below 2,000 RPM, but so let's see. Yeah, so I couldn't get it to start the long way, but once it gets going, it's fine. It seems to work. Anyway, stay tuned. All right, so really quick, I decided to see what this guy can do. So I connected the outputs from both of the outputs, and I'm pumping it into this multimeter. I'm getting like 50 volts, over 50 volts. It flucks around a little bit. I'll have to connect it to a capacitor. Actually, I'll have to connect it to a diode. I mean a rectifier. Yeah, everything's getting a little bit on the hot side. The bulbs are anyway, because it's not really. Actually, what I'll need to do is I'll need to connect the bulbs and then connect these junctions to the bulbs. But I'm getting about 50 volts, which is really usable. And what I'd like to do with that is power my Newman motor with it. So run this guy to power the Newman motor and see what happens. Stay tuned. Yeah, I'm getting about 60 volts DC when I connect it to my little homemade rectifier. But what I really need to do is connect it to a, that's a beast. Yeah, everything's getting kind of hot. The transistors are fine, it's the neon bulbs. Yeah, I'm getting about 60 volts. Let me turn it off. So apparently just connecting it to the rectifier is not good enough to shunt a lot of the back EMF. Let me try to figure out what I can do, but I'm getting a lot of good DC, so stay tuned. All right, so I've got it going to this 450 volt cap, and I just ran it up and it immediately got up to a couple of hundred volts. I don't know. Yeah, so from there, let me see what I can do. Let me get my stand so I can show you what I'm talking about. Come on, get in there. All right, let's get this guy up so you can see him. I got this multimeter for free. It's not a bad one either. All right. Yeah, we're up to 142 volts. 150. Yeah, the neons are nice and cool now. So yeah, let me see what I can do with that. Let me see if I could. I mean, I should be able to run one of my other pulse motors off of this pulse motor, so stay tuned. All right, so I've got it running, and it's running this little pulse motor, but I'm getting no output from this pulse motor. In fact, it's not even enough to light the LED, but it is running it. I thought maybe it wasn't, but it is. Let me turn it down a little bit. Let me turn it up just a hair. So I can run other pulse motors off of this beast using this fantastic circuit. And it must be working really well because the back EMF is not going to the neons at all. It's all going to the cap, which I have no idea what it's at right now. So I've always wanted to try this. One pulse motor running another pulse motor. I mean, I figured it would work. Now this is running it without the iron core because I don't have the coil securely mounted. Let me see what would happen if I put the iron core in and hold the coil while I do it. Oh yeah, I could feel it pulsing. Still no output though. All right, let me shut everything off so I can let go of this. Yeah, it's definitely working. So now I got to try the Newman motor. This is that little inexpensive Bedini. I mean, I love it. Guy did a fantastic job. But I put the bulb on the charge port, hoping it would put some output in there. And no go. I think because this charge port is putting out DC, and this is an AC bulb. That's my thought anyway. This thing turns out to be a beast, man. But the star of the show is this circuit. Dual JL94 circuit. Awesome. Awesome circuit. And of course, I can't take away from this beast rotor either. It's a monstrosity. All right, stay tuned. So I've got this guy, which is struggling. You can see he's struggling. He's not struggling, but he's pumping power into the cap. The cap's going to this very old JL94 circuit. And you can hear that guy humming. Now this is not how it's, oops. Let me see what would happen if I take this off. Because this guy seems to be struggling. And this guy is flying. Here, let me put this guy down and try something. I mean, he's still going. Yeah, whoops. He's still going. Gotta be careful, those caps, man. That's 450 volt. It won't kill me, but it will damn sure hurt. Whoop. All right. I think I might have blown the cap. And now at least this circuit's good. Let me turn this guy off. Yeah, this was a really old JL94 circuit, but it did run the Newman motor well. I think what I'm going to have to do is get my my other super cap bank and break it apart and use individual super caps instead of this guy. I think this guy is still good. I mean, let me see. I mean, something sparked. I don't know what it was. Whoops. Let me see what we got here. Let's take that guy off. Let's see what we got. It's okay. It's up to 8. It's at 84 right now. So the cap is all right. I think it just sparked because this was loose. The lead was loose. Whoops. All right. So this beast can run this guy. But it looks like the JL94 circuit eats up a lot of power because he was struggling to run. But he ran. All right. What I'd like to do is set up the Newman motor the way it's supposed to be and then run it off of this. But I'm going to change out and not use this cap. Well, no, I think this cap will be okay. I mean, it's rated for 450 volts. I don't think this guy's going to put 450 volts into it. All right, stay tuned. So I think that's all I'm going to do for this weekend. Because what I really, really, really need to do is clean up my shop. I mean, look at this. That's why things spark and fly and get all messed up, because I'm way too crowded. I mean, look at this. This is supposed to be a workbench right here. It's a workbench, all right. Somewhere underneath all that crap is a workbench. And this is supposed to be a workbench. So I think for the next week, I mean, I'll probably put something out. I definitely still want to continue on my frictionless, or my I forget what that's called. The motor from Redesign 3DP. This guy here. And then I also want to do his version of the Newman motor, because I really like that setup. In fact, now see, I'm getting ready to not do what I said I was going to do. I should wind the coils though really quick. No, I got to clean up. I really got to clean up. It's been fun revisiting some of these old rotors of mine, some of these old pulse motors. I forgot how powerful this guy could be with the right coil. Anyway, thanks for watching.